Alright class, so in this video we're going to start talking about chapter 8, which covers hypothesis testing. So I want us to think of the easiest way to get the idea of what hypothesis testing is in our heads. So I think it'd be best to work through an example, a very casual example, and then we'll formalize that technique with equations. So let's talk about Jill, because I'm so creative with names. Jill claims she can read your mind, okay? So you decide to put this claim to test, and you make 5 cards, waves, stars, squares, circles, and moons. You will draw a card, and Jill will guess it, and then you place that card back in the stack and shuffle. And we're gonna let her guess 10 times, okay? So we're gonna wanna know how many times is she correct out of the 10 possible guesses. So first off, we need to assume Jill is not a mind reader, right? Maybe even mind reading is not possible. Next, if Jill is not a mind reader, what is her chance of guessing the card correctly? Okay, so there's 5 different cards, and she's only going to pick one, so she's got a 0.2 or 20% chance of randomly guessing the card correctly. So now, let's say we do the experiment and Jill correctly gets 5 out of the 10 correct. Okay, so for every turn we drew a card, she'd guess it, we'd put it back in, we'd shuffle, and she'd pick again, okay? And she gets half of them right. I feel like that's pretty good. So here's our proportion of correct guesses. Now, if she's not a mind reader, the proportion of correct guesses should have been 0.2, right? She would get about 1 out of 5 correct. So we need to see, is this statistically significant, the fact that she got half of them right? Okay? So, by random, okay, chance, Jill could get more or less than 0.2, so 2 out of the 10 correct. It is possible that Jill guesses 3, 4, 5, or even 8 correct, okay? So, however, how likely is it that Jill would guess 3 correctly? How about 4? How about 9, right? The probability of getting 3 out of 10 correct, right? Oh my gosh, you guys, my cat is crying. Bobby, it is okay. I am trying to record a video here. Okay. So clearly by sheer chance, she can get more or less than 2 correct, but we need to calculate the actual probability. So let's do that, okay? The proportion of the time that Jill can't read our minds, that Jill guesses correctly if she can't read our minds, is 0.2, okay? When we did our experiment, right, we got a 0.5, okay? So what I need to know is how likely is it that she got lucky, right? Is that happened in a statistical significant manner, or did it just happen by chance? And we can use our normal curve knowledge to find that probability. So what am I doing? Okay, I'm looking at a proportion distribution, right? This is a distribution of sample proportions. And remember that the distribution of sample proportions equation is p hat, so that's the probability we got in our experiment, minus the probability we were expecting over p, and then q, which is 1 minus p, oops, over our sample size, which was 10, okay? So we're gonna get 2.37. What does that tell me? Well, that tells me, in a different color, oops. That tells me that here we have our population proportion. The likelihood of her getting 0.5 was plus 2.37 standard deviations above the mean, right? So what I'm looking for is the probability in this little area right here. What's the likelihood that she could have gotten 0.5 or higher by chance? So let's take a look at this. So we go to our Z table, and that's going to tell me the area over here. I don't want a highlighter anymore. That's going to tell me my area on this side of my graph. So I looked this up in a Z table. My z-score 2.3 is related to the area of 0.9911. Okay. So the next part's a little more tricky. We just witnessed Jill be correct 0.5 or 50% of the time. If she had done any better than that, it would just be even more evidence that she was reading our minds. So let's just use the Z table. So by chance, the chance that Jill would get a 0.5 or better is going to be 1 minus the area under this normal curve, right? Because we want to find the area right here. And we get the area of 0.0089. What does that tell us? So if Jill is not a mind reader, we just witnessed something that only happens 0.0089 or 0.89% of the time. So roughly 9 in 1,000, okay? If Jill is a mind reader, what we just witnessed is so rare, so we're forced to make the assumption that she is correct and really is a mind reader, and she's going to be correct more than 0.2 of the time. So, what I'd like you guys to do for Chapter 8 is go back and read the book first, okay? I put the source on our class website, but I want you to read through Chapter 8, okay? Then come back here, finish the slides, and keep that Jill example of proving that she was a mind reader, because we're going to be applying our knowledge of probability to a lot of different scenarios.